Hello guys, this is Justin Bibilan and welcome to this episode of Don't Panic, It's Organic.
Ilalaban kahit kanino, oo, simple lang ako at malabo mong magtipuhan. Kaya okay nang kahit sa FB mo lang mapusuan. Kasi di na mapigilan ng sariling mapaibig sa iyo. Ano ba to? Gusto ka laging
Okay, now let's move on to our next topic. So, naming alkanes or nomenclature of alkanes. Okay, so how do we name alkanes? So, the naming for alkanes is actually governed or established by the IUPAC nomenclature system or International Union of Pure and Applied Chemistry. So, we have 5 steps on how to name alkanes. So, step 1 is determine the name of the parent compound. So the parent compound is actually the longest continuous carbon chain in the compound. Okay, so how do we do that? So you number your carbons. Okay, so and after that is you determine if that chain or that continuous chain is actually the longest continuous carbon chain. So for example here, number 1. So if we're going to number this carbon like 1, 2, 3, so that carbon chain is actually the longest. Okay. So we have also the second example. So we have 5 continuous carbon chain, which is actually the longest one. Okay, so if you're going to number this as 1, 2, 3, then on this carbon, instead of going to that way and this way, so you would attain to have a smaller number of continuous carbon chain. Okay, so you have 1, 2, 3, and 4. So if you do it on that way, like 1, 2, 3, 4, 5, so in that case, that would be your longest continuous carbon chain. So that would be your parent chain. Okay, so it's either you number your longest continuous carbon chain on that way or the other way. So depending on that would be our next step or the following steps. Okay, so because there are actually rules on how do you number your carbon. Okay, so according to what substituent is actually bonded to that carbon. Okay, so the first step would have you number your continuous carbon chain. That's actually that would attain you to have a longest, okay, or the longest continuous carbon chain. Okay, so since 5 is the longest, then your parent compound would have a name to be pentane. Okay, if 3 is the longest chain, then the parent name would be propane. Okay, so the next one is that, okay, you can number this as 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so therefore 9 would have been the longest continuous carbon chain. So if you are going to go this way, 1, 2, 3, 4, 5, 6, 7, 8, then you would have you would attain only 8 carbon chain. Okay, or then the continuous carbon chain would have 8 only. Okay, so remember that it should be continuous and you cannot number it just like 1, 2, 3, then 4, then your number 5 would be here. So it should be continuous. Okay, you should not escape one carbon. Okay, so that's it. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be your longest continuous carbon chain. Okay, so if it is 9, then the name of your parent would be nonane. Okay, so if it is 8, then it could be octane, then 7, heptane, then 10, decane, 6, hexane, 5, pentane, and so on and so forth. Okay, rule number 2. Number the parent chain to give the lowest number to the carbon bonded to the first group encountered, or what we call the substituent on the parent chain, regardless of the numbers that result for the other substituent. So if you number your parent chain you number it in such a way that your substituent would have or would attain the lowest number for that carbon chain. Okay, so for example, so we have other examples, but first let's go to number 3. Name and number each atom or group attached to that parent compound. So the number tells you the position of the group on the main chain, and the name tells you what type of substituent is present at that position. Okay, so these are some examples of the substituent. So it could be our alkyl group, the one that I discussed already earlier, and also your halogens. So if the substituent is F, then that would be fluoro. Okay, if it is Cl, then that is chloro. If Br, that is bromo. If I, that is iodo. Or an alkyl group like your methyl, ethyl, propyl, or the secondary, the isopropyl. Okay, so and the primary and secondary and tertiary butyl. Okay, that would be also an example of substituent. So it depends. Okay, so recap. So you should number your parent chain in such a way that these substituents would attain the lowest number of that carbon. Okay, so I have here an example. Or is my example. Okay, so yeah. So the first rule is you need to have the parent compound or the parent chain or the longest continuous carbon chain. So that would be 1, 2, and 3. So that would pertain to propane. Okay. Then your number 2 is there is actually a substituent which is Br, which is actually the bromo. So that means that is the substituent there would be 2-bromo. Okay, so that is correct. 2-bromo. So in this case, the carbon number 2 is actually have a substituent, or there is an atom that is attached to it, which is a Br, which is bromo. Okay, so the name of this compound would now be 2-bromo propane. Okay. Okay, the next sample. So rule number 1, you should number your carbon chain with the longest continuous carbon chain. And rule number 2 is, and when you number the parent chain, the substituent would have to attain its lowest number. Okay, so you have 1, 2, 3, 4, 5. So this would be the longest, not the other way around. Okay, so if you have 1, 2, 3, 4, so there is also 4 continuous carbon chain, but the longest would have 5. Okay, so if you number this going to that way, 1, 2, 3, this substituent would attain the lowest number. Okay, if you are going to number this 1, 2, 3, okay, that would be the same also. That this substituent would also have attained its lowest number. Okay, so 1, 2, 3, 4, 5. So your carbon number 3 has a substituent which is an alkyl group, which is a methyl. So that is, so the name would be 3-methyl, and the parent name is, and the longest continuous carbon chain is 5. So therefore the parent name is pentane. So that would be 3-methyl pentane. Okay. So the last example. So 1, 2, 3, 4, 5, 5, 6, 7, and 8. So this would have been the longest continuous carbon chain. Okay. So not this way, like 1, 2, 3, 4, 5, 6. That is only 6. Okay. So 8 would be the longest continuous carbon chain. So if 8 is the longest continuous carbon chain, then the name of the parent compound is octane. Okay, so how about the substituent? So are we going to number this like this way or the other way around? So if you're going to number this like that, like 1, 2, 3, 4, your substituent is actually attached to that 4 carbon. While if you are going to number this on the other way around, 1, 2, 3, 4, 5, your substituent is actually located on the 5th carbon. So rule number 2, your substituent should attain the lowest number of carbon that is attached to it. Okay? So therefore, you should number this longest continuous carbon chain on this way. Okay, like 1, 2, 3, 4, so that your substituent would attain the lowest number. So the name would now be 4 ethyls because this is an alkyl. Okay, that is actually ethyl because it has 2 carbons. Okay, so that is ethyl. So 4 ethyl octane. So that is correct. Rule number 4. If the substituent occurs more than once in the compound, a separate position number is given for each and the prefixes di, tri, tetra, penta, and so forth are used. So if there are substituents that are actually the same, and if they appear twice, then therefore we can use di. So that means that this substituent occurs twice on this structure, and if it actually occurs thrice, so therefore we can use the prefix tri. Okay, and if it actually if it has 4 same substituent on the structure, then we can use the prefix tetra, and if there are 5 same substituent, then we can use penta. Okay, so for example, on this structure or in this compound, okay, so the longest continuous would be 6, like 1, 2, 3, 4, 5, 6. And you have your substituent BR that is actually on number 2 and number 5. So therefore, you can name this compound like 2, 5. So since they are the same substituent and they are only 2 the same substituent, then you can use the prefix di pertaining to that substituent which are actually the same. Okay, so 2,5 dash dibromo, which pertains to 2-bromo that is attached to your parent compound. So 2,5 dibromo hexane. Okay, so your parent has 6 continuous carbon chains, so that is actually hexane. Okay, then you have your 2 bromos attached to carbon number 2 and carbon number 5. So the name would now be 2,5-dibromohexane. Okay, the next example. So, determine the longest continuous carbon chain. That is rule number 1. So 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So you notice that if you are going to number your carbon chain on that way, you would have attained the lowest number of the substituent, okay, in that carbon. While if you are going to number this on the other way, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So your substituent would have a great number or have a bigger number compared to the other the other way that we number the parent compound. Okay, so in this case, if you are going to number this on that way, your substituent would have 3, 5, and 7. While if the opposite one, your substituent would have a 4, 6, and 8. So which has a smaller number. So that way, okay. So we can number the parent compound on that way. Okay. So therefore, our parent compound contains 10 carbons. So that means that is a decane. Okay. So where are our substituents? We have it in carbon number 3, carbon number 5, and carbon number 7. So carbon number 3 contains a methyl group. Carbon number 5 also contains a methyl group. Carbon number 7 also contains a methyl group. So rule number 4, if they have same substituent, so we can use the prefix pertaining to how many same substituents that is actually there in the compound. So there are 3 same substituent, 3 methyl, so we can use the prefix tri. Okay, so the name would now be 3, 5, 7 trimethyl decane. Okay, so that would be the name. So not 4, 6, 8. Trimethyl decane. Okay, next is rule number 5. Okay, the last rule. Place the names of substituents in alphabetical order before the name of the parent compound, which you wrote down in step 1. Numbers are separated by commas, and numbers are separated from names by hyphens. Okay, by convention, halogen substituents are placed before alkyl substituents. So if there are different kinds of substituents that are actually present in your compound, then you should have to write it on alphabetical order. So in this case, like this example, so rule number 1, you have to number your parent compound. Okay, the longest continuous carbon chain. So that would be 1, 2, 3, 4, 5. Okay, so you notice that if you're going to number it as 1, 2, 3, 4, 5 in that way, you would attain to have the lowest number for the substituent. Well, if you're going to number this on the other way, on the opposite, okay, 1, 2, 3, 4, 5, you would have a bigger number for the substituent. So the numbering for the parent would be that way. Okay, so your carbon number 2, there is an attached bromo or bromine there. So that would be 2-bromo. And your carbon number 3 has 2 same substituent, which is an alkyl or what we call the methyl. So that would be dimethyl. Okay, so alphabetical order. So bromo should be the first one. So that would be 2-bromo. Then followed by the next, which is actually methyl, and they are the same, so therefore these are actually 3,3-dimethyl. Okay, so pertaining to 2-methyl on the carbon number 3. So that would be 3,3-dimethyl, and the last would be our parent compound. The parent name is pentane. Okay, always remember that in writing your IUPAC name, the numbers are actually separated by comma. So if there are 2 to 3 numbers, they are actually separated by comma. Then the number and the name are actually separated by a hyphen. Okay, so if you have 2 hyphen, then bromo. Then a hyphen again. Then if there are 2 numbers, then you can separate them using a comma. Then you have your hyphen and a name. Then your parent name. Okay, so that is only basic and so very easy. Okay, so you can pause this video if you want to answer this example. So what would be the name of this compound? So you can pause this video and try to answer this. So I will give you the answer on this video also. Okay, so rule number one, you have to find or determine the longest continuous carbon chain. So that would be 1. So if you're going to write this as 1, 2, 3, 4, 5, 6, your substituent would have a bigger number. Okay? So while if you are going to write the number of your parent continuous carbon chain on the opposite, you would get a smaller number for your substituent. Okay, so the numbering would now be coming from here. So this would be your number 1, and this would be your number 2. Okay, then that would be your number 3, then 4, then that would be 5, and this would be number 6. Okay, so that your carbon number 2 would have substituent of the Br. Okay, so if you're going to number this on that way, carbon number 5, the number for bromo would be 5. Okay, so that would have a bigger number. So rule number 3 or number 2, your substituent would attain the lowest number. Okay, so that would be the numbering system for your parent compound. So the name would now be 2. So you have starting from your substituent. Okay, that would be 2-bromo. Okay, 2-bromo. Then what is the name of your parent name. So it has a 6 carbon. So therefore, that would be hexane. So the answer would now be 2-bromohexane. Okay? So very easy. So the answer is 2-bromohexane. So next example. So you can pause this video if you want to answer this. Okay? So what would be the name of this compound? So rule number 1, you locate or you determine the longest continuous carbon chain. So you have 1, 2, 3, 4, 5. Okay, so you can also go to the other way, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. And you should also know that rule number 2 would have, you should make it sure that your substituent would attain the lowest number. Okay, so if you're going to number this on that way, like 1, 2, 3, 4, 5, your substituent would have carbon number 2 and you have 2, 5. So that becomes 2, 5, 5. Okay? So 1, 2, 3, 4, no, 2, 4, 4. I mean, okay, that is wrong. So 2, 4, 4. So 2, 4, 4. Okay, so 1, 2, 3, 4, 5. Okay, so 2, 4, 4. But if you're going to number this like 1, that would be your carbon number 1, number 2, number 3, number 4, and number 5, then you would have a number that is actually 2, 2, 4. Okay, so which of these sets of numbers are actually smaller? Okay, so this set of numbers. So the numbering would be that way. Okay, so 1, 2, 3, 4, 5. And remember, your substituents are all the same. So what is the name of your substituent? That is actually methyl. Okay, so how do you write the name? That becomes 2. Okay, they're actually the same. So you just write the number from where it is attached to that carbon. So you have 2 methyl, so that becomes 2, 2. Okay, and the the other methyl is attached to carbon number 4. So 2 to 4. Then hyphen. So there are 3. So that means that is tri. Okay. So 2 to 4 trimethyl. 2 to 4 trimethyl. Then the longest carbon chain is 5. So therefore that becomes pentane. Okay, so 2 to 4 trimethyl pentane. So the answer is this one. Okay. 2 to 4 trimethyl pentane. Okay, next is this. So what would be the name for this compound? So same, you locate the longest continuous carbon chain, and in this case, this is very obvious. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be the longest. And make sure that if you're going to number your longest continuous carbon chain, the substituent would attain the lowest number for that carbon that is where it is attached. Okay? So that if you're going to number this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, your substituent would have the number 5 and 9. While if you're going to number this on the opposite, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so your carbon would your substituent would have the number of 2 and 6. Okay, which is actually smaller than 5 and 9. Okay, so the numbering should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore, your 2 and your 6 have the same substituent, which is actually methyl. Therefore, that would be 2,6-dimethyl, and your parent is 10-decane. Okay, because it is 10 carbon chain. So 2,6-dimethyl decane. So the answer would be 2,6-dimethyl decay. Very easy. So now it is your time to answer this. So you can pause this video and try to answer these four compounds here. Try to name them according to the IUPAC nomenclature system. Okay, A, B, C, and D. So it's your time to answer this now. Okay, so you can pause this video. Then I will give you the answer. So the answer for letter A would now be 2,3-dimethylbutane. For letter B, that is 2,2-dimethylpentane. So letter C, that is 2,2-dimethylpropane. And letter D is 1,2,3-tribromopropane. Okay? So realize yourself if you have the correct answer and why is it that these are the answer for this these are the name for that structure. Okay, so maybe you have neglected some of the substituents, or the number of your parent longest continuous chain is different. Okay, or there is actually there is a one continuous carbo chain that is the longest, and you have mistakenly number your parent chain. Okay, so realize yourself that these are actually the answers for this problem here. Okay,